In my lab, we're looking at the high-speed fiber optic systems. And we have optical transmitters and receivers. They're all high speed. 25 years ago or 30 years ago, when I was working at the industry, we're looking at 10 gigabit per second per channel. Now it was about 1 terabit per second per channel. So that's about 100 times more. So that's why all the electronic circuit, optical circuit, they have to be much more powerful. That's why we need a lot of equipment and a lot of fibers. You know, these spools, they're all optical fibers and with different kinds of optical amplification. And also there, we just get a very high-speed oscilloscope. That will give you a bandwidth on the order of like 65 gigahertz. So that's very high. So that's why we want to, we work on optical signal processing and electronic signal processing, and also in the digital signal processing. So that's all our focus.
So my name is Peter Cho, and I work on optical neural networks. So what we have here is essentially the test bed. And so we have this laser that projects onto this DOP mirror that basically generates a image onto this PLM. So this PLM is a phase mask. So your images, so in this case, the Luminous data set will be encoded as intensity, and this phase mask would put a phase on it. And then we have this lens setup, which basically does like an FFT, and this would be captured by this camera over here. So basically what we're trying to do is have this setup be a real-time neural network. So basically you would want to generate an image, it captures it, and then you can update it. So that requires high speed, which is why we really need to use these mirrors. Because the environmental impact of this is that it uses a lot less power than your traditional machine learning setups. Because your traditional machine learning setups, you require to program it on the CPU and GPU, and that uses a lot of power. Once this phase mask is trained, it requires basically no power. The only power you actually need is to use the laser and configure the images. Very little power compared to, let's say, running a full-scale GPU, which uses like 100-ish watts.
I am Shalmali. I am a PhD student, a PhD candidate at Dr. Rui's lab. Right now, I'm working with a quantum wave laser. I am trying to measure the RF line width of the laser. This is a part of my project. I'm using a RF spectrum analyzer to measure the line width of that quantum wave laser. And the next part of my work would be to get the dispersion compensation of the laser so that I can get a optical pulse which is narrow enough. So basically what's my main goal is the quantum wave laser that I'm using, it's optical frequency comm, and I want to establish short haul communication. So maybe 20 or 40 lines from the laser. I can use all the lines for the communication purpose and get a high speed short distance communication for, you can say data center applications and stuff like that. So that's the bigger goal of the project. With the newer technology, every day we are going towards 5G, 6G, and maybe in some next few years it will even go higher, right? So we are always looking for high-speed communication and more speed and more data transfer. So obviously, if things work out properly, then it can help not only Kansas, all states of US or even the world.
So this one is the fiber cable, really, installed in fiber optic systems. But sometimes this cable, if there is a vibration, then we want to measure the vibration. If a car drives by, there's small vibration, in your office you can track where the car is, how fast that moves. And this project is for an oil company because there is a fiber cable on the oil pipeline. So they want to see if the oil pipeline has a leakage. That might be, some sound wave. So we want to find out using the existing fiber cable. If I am applying a vibration right here, you hear? If I apply a vibration over here on this little plate, I can control. From my equipment over here, I can measure, that vibration causes the polarization change of the optical signal. So that could be hundreds of kilometers away in your office. So that is a project we try to calibrate. So in terms of benefit to our state Kansas, right now there are a lot of fibers installed underground across the state. So if you can measure any small vibrations everywhere, that may allow you to find, if there is for traffic, you can also you can monitor the traffic. You can also monitor earthquake if there is any in Kansas. So and also some structural damaging or some stress in the bridge and everything that can be found out.